Hey pre-calculus, we're back with a new video, 4.3. We're no longer graphing the exponential functions, but we're solving them. And I threw in some inequalities too. This will be fun. So the first thing that you guys need to be able to do prior to any of this is understand the idea of writing numbers like this with a base and an exponent. So, for instance, 9 is 3 squared. 27, 3 to the third power. That's what I mean by rewriting each pair as powers with the same base. Same base, probably different exponents, right? So when you think about 125 and 625, ask yourself, what times itself a certain number of times will give you 125 and 625? Well, 125 is 5 times 5 times 5. Times 5 is 625. See where I'm going with this? All right, and then you can do the same thing with 8. Now, a lot of people will try to write 128 as a power of 8. But 8 times 8 is 64. 64 times 8 is 512. So what we got to do is we got to break it down once more. So in this case, 2's work. 2 times 2 times 2 is 8. And let's see. Oh, 128 is 60. I'm sorry. I didn't actually write that, did I? 2 to the third power is 8. Yeah? And then 128 would be 64 times 2, right? And 64 is 8 times 8, which is 2 to the third power times 2 to the third power times 2 to the 1 power. If you're multiplying powers with the same base, you just add the exponents. 3 plus 3 plus 1 is 7. Okay, so make sure you guys understand how I got that, because it's going to be a pretty significant skill required to have any success on this stuff. Okay. So now that we've mapped out what it means to be powers of the same base, here's the idea. If I am dealing with equations that have exponential properties on both sides, my main goal should be rewrite each power on both sides with the same base, if possible. If possible. So is there a common power between 9 and 3? Yes. 9 equals 3 squared. 3 equals 3 to the 1 power. So here's what I'm going to do. I'm going to take this 9 right here, replace it with 3 squared. So that's going to be 3 squared to the 2x minus 1 power. See what I did there? I took out the 9, kept the 2x minus 1 power, and replaced the 9 with 3 squared. Now the other one, you don't really need to do anything. I guess if you want to, you can say replace the 3 with 3 to the 1 power, but it's not going to change anything. At this point, you guys really need to understand your rules of powers. If I have a power to a power, I'm going to multiply the two exponents together. So you're going to take 2 times everything here. So it's going to be 3 to the 2 times 2x minus 1. Over here, it's going to be 3 to the 1 times 6x. Now here's the cool thing about this. Once you have the same base, you can use logic to say, look, if they both have the same bases, you can just solve what you see in red. They should equal the same thing if their bases are equal to each other. So you can ditch the bases and solve the red. So the red is going to be 4x minus 2, I've ditched the purple 3's, is equal to 1 times 6x. All right. And now we have such a simple equation, it's almost too easy. There's your answer. Let's check out number 2. Seems like 5 is the same base that we're looking for. I don't need to put 5 to the 1 power. I'll just make it 5 to the 5x here. On the other side, I've got 5 cubed is 125. Wait a second. Should I be putting that in red? Yeah. And take that to the x plus 2 power. Ditch the base, and then take 3 times x plus 2. Get x by itself. Yeah, I mean, that's pretty simple. Try 3 on your own. Pause it. Try both 3 and 4. There's a challenge for you. All right, you've paused it. I'm trusting you paused it. What is the same power for both 8 and 16? It's weird. It seems like everyone's drawn to, hey, double 8, you get 16. But then they think that 8 is somehow a base that gives you 16. 8 squared is 64. What you got to do is say that they both have a base of 2. Okay? 16 is 2 to the 4th power. 8 is 2 to the 3rd power. Got to do that first. Then you ditch the purple bases, rewrite the red exponents. It's going to be 4 times 2x minus 3 is equal to 3. Just distribute. You got 8x minus 12 equals 3. And it turns out to be a slightly wonky answer. It's going to be 15/8. Or 1 7/8. Or 1.875. Whichever you choose, I don't mind. All right, so what did you guys come up with number 4? That's certainly different. Probably off to the side, it'd be good to just, think some things about, what is 32? 32 is 2 to the 5th power. Yeah? So 1 over 32 is 1 over 2 to the 5th power. Sorry, you guys can't see that. Bad habit. All right, now, there was this rule of exponents where if you take 2 to the 5th power, put it on the bottom, that's the same as, that's the same as 2 to the negative 5th power. This right here, if we rewrite it with a base of 2, we can just make it a negative exponent. Nice. Now we can say, this is just regular 2. And this is just regular 2. This is to the x minus 4. This is to the negative 5 to the 2x plus 5. And now you just ditch the purple. Get rid of that purple and solve the black ink. So it's -5 times 2x plus 5. Work some solving equations magic that you learned all the way back in 8th grade, Math 1. Get the x's together, not the y's. Get the x's together on one side. Get the constants together on the other side. And you get 11x here is equal to -21. Divide both sides by 11, and you get x equals -21 over 11. So what more is there? These are pretty much kind of more of the same. If you want to, just pause the video. I'm just going to work it out super quick. Try it on your own. See if you got the right idea. I might have went a little bit overboard with the number of examples here. This will be 2 squared, 3x minus 2, 2 to the 5th. Yeah, probably didn't need this many examples. This will just be 2 times 3x minus 2 equals 5 times x plus 1. Get rid of parentheses. Subtract the 5x. Add the 4. 1x is equal to 9, which is the same as just x equals 9. All right, yeah, nothing to it. But we are sticklers for details, aren't we? This will be 3 squared to the 2x minus 1. 243. That's going to be 81 times 3. That's going to be 5 3s, but it's going to be to the -5 power. Drop the same bases and solve. All right, wow. Whew. Do we have enough endurance to figure the rest of this out? All right, so inequalities. Now we know with quadratics or anything with polynomial structure beyond to the 1 power, those were deeply affected by inequalities. Like the inequality solution wasn't simple. Same thing with rational functions, the ones with the fractions in them, but we never really dealt with a constant base and an exponent that was variable. Well, we got it now. So 625 is 5 to the 4th power. I'm going to go back to color coding so that we can very much see what's going on here. That's to the 7 minus 2x. Still greater than. All I did was manipulate the left-hand side, which did not fundamentally change anything at all on the right. On the right, it's still 5 to the x plus 8. So the question becomes, if the bases are the same, can we say that the inequality still holds to the exponents? We can. You can still just drop the bases and solve it like it's normal. That's good news. The less complicated, the better. So I'm going to move the x's to the right, the constants to the left. 20 is greater than 9x. So we divide by 9, divide by 9. This is going to be 9, 18, 2. With 2 leftovers, 2 and 2 ninths is greater than x. Just keep in mind that this is the same as x is less than 2 2/9, which is the same as the solution set negative infinity to 2 2/9. So either of these would be okay. Yeah. So now, pause the video and try 8 on your own, and then we'll call it a day. All right, let's see if you're correct. 125 is going to be 5 to the third power. Since it's under 1, we're going to give it a negative. We can take the whole thing to the x plus 3 power. Still less than or equal to, because all we did was simplify and manipulate the left-hand side. 25 is 5 squared. Take that to the x minus 5 power. Kind of like the way that sounds. Take that to the x minus 5 power. And then you got negative 3 times x plus 3. Power to a power means multiply. Still less than or equal to 2 times x minus 5. Make sure you can see the whole thing. All right, and we're 16 and a half minutes in. Got to get through this. Negative 3x minus 9 is still less than or equal to, we just manipulated the left, 2 times x, 2 times negative 5. I'm going to move everything to the x's left on this one, and then add 9 to both sides. So that gives me negative 5x on the left, still less than or equal to, this will be negative 1. Here's the kicker. You got to remember, when you divide by negatives, it flips the symbol. Dividing by a negative fundamentally changes an inequality, right? 1 is less than 2. Yeah, that's true. Divide by a negative 1. Negative 1 is not less than negative 2. You got to flip it in order to make it true. Okay? So, x is greater than or equal to positive 1/5. And that's your answer. Or bracket 1/5 to infinity. Hey guys, thanks for watching the whole way through. I really do appreciate it. Make sure that you post those notes. Post that homework, and hopefully we're making progress. Thanks for watching.